Hello, welcome to this video. So this video will be about a conventional question of paper 1 in DSE about application of trigonometry in 2 and 3-dimensional problems. So first of all, in part A, here we have a thin metal sheet A, B, C, D is in the shape of trapezium. So it's like this. Trapezium. Okay, good. A, B, C, D. Okay, so A, B, C, D. Be careful about the naming. A, B, C, D is in the shape of trapeze, and V, D parallel to B, C. So, like this. Good. It's given AB equals to 45 cm, and then the angle ADC equals to 70, and then BAD equals to 50. So, we are asked to find CD. Okay. So, in order to find CD here, so I'm afraid, okay, so we need to translate the AB, translate this sign to right. Okay, good, like this. For such that they are parallel. Full course. Good. And then I call this point as E maybe. Oh no, not E. Maybe F, because E will be used in the next one. Now I'm afraid this one is also 45, and then this one is 50. Good. And then okay. B. Okay, so that's why here I will try to so this 45, and then this angle will be corresponding to the green line, and then the yellow line will be corresponding to 70. So that's why here we'll try to use CD, because we want to find CD. So part A, so CD over sine 70, right? No, sine 50. Sine 50 equals to 45 over sine 70. So that's why CD will be equals to 45 sine 50 over sine 70, or equals to so that will be 36.7 cm. So that's our part A. Remember, that's part A stuff. Okay, safe answer. Good. So that's part A. And then in part B, okay, so from part A we got CD equals 36.7, so that's what I try to put here. So, and then we have this metal sheet is now given, and then let E be a point on AD such that BE is perpendicular to AD. So BE, it's going to be like this then. Okay, good. BE is perpendicular to AD. So now the metal sheet is folded along BE, okay, such that AE is, now I'm afraid, okay, so this pen is already folded up to become this. Okay, so BCDE remains on the horizontal ground, and the triangular face ABE is folded up. Okay, it's quite easy to imagine. And then I think a very, very important information here, I would like to highlight it in red. AE is perpendicular to the plane B, C, D, E. So what does it mean? So that means this. That means angle AEB is 90. Of course, angle AED equals to angle AEC equals to 90 degrees as well. That's very, very, very important. Okay, so this is 90. This is 90. And don't forget, this is also 90 because of this. Okay, and this is also 90. So many 90 degrees. Good. And then and then we try to insert the other 3 faces, okay, to become a pyramid. And then PC equals to 40. Okay. So now we try to find angle CAD. Angle CAD. So we want to find this. So of course I'm afraid, okay, here we need to gather all the phi size. We need to gather all the phi size of this triangle. So all the phi size we need to know. CD is already found, is already given. It's 36.7. Okay, so that's the answer of A. We can put it down. Okay, so that's very important. Okay, now okay, so we need to find a lot of size. Okay, so now first of all we need to find so many, right? So maybe we need to figure out AE first. So AE, well, basically we try to make use of this right angle triangle. So from this right angle triangle, so BE will be equals to 45 sine 50. So that would be, that's BE. So it will be 34.5. And then AE will be 45 cosine 50. And by using calculator, so that will be 28.9. And then now we have AE. Okay. And then maybe we need to find DE as well. So DE would be approximately equals to 36.7 cosine 70, and then plus 40. So that would be DE, that would be 52.5. So up to now we have 3, and now we have, let's do EC then. EC we can use Pythagoras theorem. Don't forget here AEC is 90 degrees, so that's why we can use Pythagoras theorem. So in the 34.5 square, and then plus 40 square. So we're using this. Okay, to find AC, to find EC. Okay, if we can find EC, then we can find EC. So EC, so it will be 52.8. Okay, so all the size, okay, using the trapezium, okay, has been found. Now, okay, so we're gonna try to use AE, and then we try to do you have A? Oh yeah, and then we try to find AD. Okay, so AD, this side. Okay, well, bear in mind this AD, I think this AD would be not the same with AD that in part A. So that's why AD here, so that would be AE square plus ED square. AE square plus DE square, so that's my 28.9 square. And then plus 52.5 square. So that would be, okay, that would be, how long is it? So 0.0. Okay, so and then after that, we need to find this. Okay, so this one, we'll try to consider this. Okay, so don't forget AEC is 90 degrees, as I stated at the very first beginning. So that's why, so AC would be AE square, so 28.9. Well, again, oh yeah, of course. And then plus EC square, so that would be 52.8 square. So that will be approximately 60.0. I mean 60.2. And now we have 60.0, 60.2, and then 36.7. But finally, we can handle angle CAD. So that's why, so cosine of angle CAD. So we try to make use of the cosine formula. So that would be 60.0 square, right? Yeah. And then, well, never mind. Just hold it then. Okay. So this one, cosine of angle CAD. So long fraction, actually not very long. So 60.0 square plus 60.2 square minus 36.7 square over 2 times 60.0 plus 60.2. So that's why angle CAD, by using the calculator, that would be 35.5 degrees. Whew. Okay, so that would be for B1, for very lengthy steps. Very lengthy steps. Okay, so here comes the last part. So it's about B2. So does the angle between the plane BACD and BCDE exceeds 30 degrees? So first of all, maybe some of us would like to shake the two planes first. So first of all, the base. The base will be a right-angled trapezium. Okay, so right-angled trapezium. And then the next plane would be, okay, so this is yellow, this is green maybe. And then you can see the two planes would intersect at line CD. Okay, line CD. Good. CD here. Okay, so that will be this. And then don't forget how to find the angle between two planes. First of all, here we need to, along the line of intersection of the two planes, we need to find a point. So such that this point, that's a Q. Okay, such that, okay, we try to draw the normals. Okay, try to draw the normals. Try to draw the normals. Okay, between the normals of line CD with point Q. Okay, the normals. Okay, the normals. Good. So this normal by the theorem of full phi perpendiculars. So if we try to have a point Q such that it is the foot of perpendicular of A on CD, well, that means Q is a point on CD such that AQ is perpendicular to CD. Okay, so with this kind of setting, so B2, so the required angle, now before we claim the required angle, so apart from AQ is perpendicular to CD, so we would like to use the theorem of full phi perpendiculars. So this foot of perpendicular, the corresponding normal on the yellow pin would pass through the vertex E by the theorem of phi perpendiculars. So that's very, very, very important. So that's why here the required angle would be angle AQE. So that's the angles we want. Okay, so first of all, already in this triangle, now of course, angle AEQ will also be 90 degrees as well, for sure. Okay, and then already we got the height, in which that will be the opposite side of the required angle. So next, okay, so unlike the marking scheme, I would like to find EQ. So how to find EQ? Do we have the photo? No. Now try to copy this. So we have this triangle. This is 70, and then this is 52.5, obtained in B1. So we just want to find this, try to find QE. So that's why QE will be basically 52.5 sine 70. So that would be 49.4. Okay, so and then after that, so if we have so this is 49.4 and this is 28.9. Good. And then we want to find this angle. So of course we just try to make use of the tangent. Okay, 20. Okay, good. 45. Where's 45? Oh, good. Nice. So good. And then that's why the final answer would be the theta would be 30.4 degrees. Slightly bigger than 30. So that's why that's the angle. Yes, okay, the angles, the required angle exceeds 30 degrees. And that's all for this whole problem. Thank you for watching.